Solving polynomial equations. Well, we've been working a lot with polynomials and their graphs and zeros, etc. And now we're going to put it all together. And our objective, we want to solve, which means to find all zeros of third and fourth degree polynomial equations. This can take a little bit of doing. It's not too bad, but it certainly does take a little bit of work. And so I've given us a number, I think I've got 4 example problems, and I've given us plenty of space for our work. We know a lot of things that are going to come into play here. Let me see if I can't get you so you can see all of it. We know what a polynomial function is. We know that we have the leading coefficient. We know we have the degree of the polynomial function. We have a constant term, and we set the function equal to 0 to solve it. We know that the degree of the polynomial tells us the total number of zeros or solutions if multiple zeros are counted separately. We know about zero multiplicity. If the graph crosses the x-axis, that zero has odd multiplicity, which means it occurs 1, 3, 5, etc. number of times. If the graph touches the x-axis and turns around, that zero has even multiplicity, which means that zero is going to occur at least twice, or 4 times, or 6 times, etc. We know about synthetic division and long division. Okay, synthetic division, I'll do synthetic division for 3 examples and long division for 1. Synthetic division tends to be the quicker method for factoring out linear factors, but long division always works as well. We know the factor theorem. If c is a root, then x minus c is a factor. And of course, we know the quadratic formula, which we're going to make use of. Opposite b plus or minus the square root of b squared minus 4ac, all divided by 2a. And the quadratic formula can be used to solve any quadratic, no matter what it looks like. Okay, what's involved with solving polynomial equations? Well, the basics are this. We're going to use the polynomial's degree to determine the total number of zeros and their possible type. Are they real or are they imaginary? We're then going to use the graph or the table to find a rational zero and thus a linear factor. We're then going to use synthetic division or long division to factor that out and rewrite the polynomial as a product of a linear factor, which we got from here, and the remaining factor, which is a nonlinear factor. We're going to keep doing that. We'll do it one more time if necessary, or it might work the first time, until we get all linear factors alongside a quadratic factor, and then we will solve the quadratic to find the final 2 zeros. So the goal is use the graph to find factors, factor them out. Once you get to a quadratic, use the quadratic formula to get to the final 2 zeros. Let's get started. That's a lot of verbiage, and it makes a whole lot more sense if we do some problems. So I have 4 example problems set up for us. Okay, example 1, find all the zeros of the function x cubed minus 10x minus 12. Well, first off, the way we do that is we set it equal to 0. X cubed minus 10x minus 12 equals 0. So now let's recognize we have a degree of 3, which tells us that I have 3 zeros if multiple zeros are counted individually. Okay, then also the third degree tells us it's odd. That tells us that the end behavior is opposite. So no matter what, this graph has at least 1 real zero. It crosses the x-axis at least once. So our possibilities. Okay, we could have the graph cross the x-axis 3 times. So all 3 zeros are real numbers. That's one possibility. It goes up, down, up, or it goes down, up, down, and all three zeros are on the x-axis. The other possibility is I could have one real zero because it has to cross the x-axis at least once, and then I could have two imaginary or non-real zeros. Okay? Now let's take a look at the graph, and let's find a zero. If we know we have one, let's find it. We hope it's rational. Let's find it. So y equals, let's clear this out. The function was up here, x cubed minus 10x minus 12. So x cubed minus 10x minus 12. I'll make sure I'm in the standard window. And here's my graph. And it turns out I have all real zeros. Now I'm curious about this one. Okay, what is going on? Does this cross the x-axis and come back? I don't know. Does it turn and touch? So is that two zeros and then a real zero here, or does it cross over and come back? Well, let's zoom in. We know that we have a zero over here, but if we calc that zero, I'm looking at the one on the right here. So I'll set up and I'll go around that one. That zero is 3.645, so that one's irrational. So this zero is irrational. I'm looking for a rational zero. So let's zoom in on this location here and see if I have a rational zero. So I'm going to go to my window. Whoops, let me go back to the graph. That's around -2. So I'm going to go to the left and the right of -2. And we'll just we don't need too much in the, I'll go from -3 to 3. And let's see what's going on at that zero. Oh, it does indeed cross. So I have 3 unique real zeros. You can see the graph goes above and comes back down. So I've got a zero here. It looks like it's on -2. And I've got a zero here between -1 and -2. But it looks like I have a rational zero of -2 here. Let's go to my table. And here it is. There's my rational zero at -2. Well, good. Okay, so the graph and the table shows a rational zero of -2. Okay, so let's factor that out. So that means that, okay, so x plus 2 is a factor, okay, using our factor theorem. So let's factor out the -2, and I'm going to use synthetic division. Okay, so I have a 1 for my coefficient of x cubed. I'm missing an x squared term, so I'll put a 0 in for that coefficient, and then I have a -10 for the x and a -12 for the constant. Okay, and I know the answer. I know I'm going to get a 0 down here because I know this is a factor, so I should get no remainder. Let's take a look and get there. -2 times 1 is -2. Add. -2 times -2 is +4. Add. -2 times -6 is +12. Add. I got my 0. But I knew that. So those are my coefficients of my second degree polynomial. So this tells me that my polynomial can be factored as x plus 2 times x squared minus 2x minus 6. Okay, we've done that before using synthetic division and long division. And of course, equals 0. Well, this is a quadratic. So I have now linear term, and I've got down to a quadratic. So I'm done with all this stuff. I can solve this. This is x equals -2, which we had already. And this is, or we got to solve this. right? If A times B is 0, then A is 0 or B is 0. Well, let's find out where this is 0. I don't believe it's factorable, so I have to use the quadratic formula. X is equal to opposite B plus or minus square root B squared minus 4 times A times C, all over 2 times A, which is 2. This is equal to 2 plus or minus. This goes into a calculator if necessary. What comes out is the square root of 28. Because this is not negative, I know that these two roots are going to be real. They'll be irrational, but they're real. Over 2. 28 is 2 root 7. So this is plus or minus 2 square roots of 7 over 2. And I think I'm still, I gotta move my sheet up a little bit here. And this is gonna be 1 plus or minus root 7. Okay, so I have my zeros. My zeros are, negative 2. I knew that one from the graph. And these two are real, but they're irrational. So 1 minus square root of 7, and then 1 plus square root of 7. And there's all 3 of the roots. I knew I had 3. If I go back to my graph and I want to check that 1 minus or 1 plus, I'll go back to y equals and my graph. I'm going to zoom standard. And I'm going to say, let's first let the graph get in there. I'm going to say, okay, I'll bet this one is 1 plus root 7. So I'll go second calc a value, and I'm going to put in the x value of 1 plus the square root of 7. And indeed, that's a 0, which it says right there. So I found them all. Let's recap, okay? I know from my degree how many zeros I'm going to have. I also know the possibilities. In this case, all 3 zeros are real. Okay, I didn't have any. I touched the axis 3 times. The graph showed me that I had a rational 0 at negative 2. So I knew that x plus 2 was a factor. I can factor it out. I use synthetic division to get the other factor, which turns out to be a quadratic. So then it's just a quadratic formula to get the last 2, and they are real, but they are irrational. Okay, give me a moment. We'll do some more examples. As I said, this does take a little bit of practice. So give me a moment. Okay, I have here another 3rd degree polynomial. And this one is x cubed minus 5x squared plus 17x minus 13. And it's already set equal to 0. I want to solve it. I want to find the zeros. So let's note it's degree 3. Okay, which tells me I have 3 zeros. Okay, now again, are they all real? Or do I have 1 real and 2 imaginary? I don't know, but I have 3. Are any of the real ones duplicated, or do I have a multiple? I don't know yet, but I have 3 zeros. So my possibilities, because it's an odd degree function, I know the end behavior is opposite. I have at least 1 real. Okay, so I could have all 3 real. All 3 are real. Or I have 1 real and I have 2 that are imaginary. I am A. Not G. I am A. Imaginary. I don't know yet. Let's take a look at the graph. Okay, what do we have? So this is my function. This is my equation, x cubed minus 5x squared plus 17x minus 13. Okay, back to here. Go to y equals, clear what was in there. X cubed minus 5x squared plus 17x minus 13. Graph it in the standard window. And here's my graph. Oh, well, I I guess I could zoom out, but this pretty clearly shows me I have one real zero. The other two must be imaginary. Let's do a zoom out and see if there's anything else that I'm missing that's a little further away. Okay, there's my zoom out, and that's not getting me any closer. I'll zoom out one more time. Is there anything else happening? Let's see here. And the graph is right there. It is clearly not crossing the x-axis a second and third time or touching it. It is simply crossing it right there near the origin. I'm going to go back, and I'm going to go back to my standard window. And there we are. It is crossing it somewhere over here near 1. Okay, so let's first say that I know that I have one real and two imaginary. It's only crossing one time. Now let's take a look. It looks like that's crossing at 1. Let's check with our table. And sure enough, at x equals 1, I have a rational 0. Well, that's terrific. So that's terrific is what I meant to say. The graph and the table, the graph shows us I have one real and two imaginary. The graph or the table shows a rational 0 at 1. This means that x minus 1 is a factor. Okay? And we can factor it out. We can take x minus 1, we can get it out of there, and we'll be left with a quadratic. Let's use long division this time. Whoops, x minus 1, not x plus 1. You can use synthetic division. I'm going to go to long division for this example. And we're going to have, let's say we have 3, 2, 1, so we have all the powers. We don't need any zeros. X. Okay, let's get started. X goes into x cubed, x squared times. X squared times x is x cubed. X squared times -1 is negative x squared. Parentheses subtract, and we're left with negative 4x squared. Let's bring down the plus 17x. X goes into negative 4x squared, negative 4x times. Negative 4x times x is negative 4x squared. Negative 4x times -1 is positive 4x. Parentheses subtract, and I'm left with 13x. Let's bring the final minus 13 down. X goes into 13x 13 times, and 13 times x is 13x. 13 times -1 is negative 13. Parentheses subtract. I have a 0 remainder, but I knew that would be the case because I know that this is a factor, x minus 1, so I know that it goes in evenly. Okay, so what do I know? I know that, this can be factored as, okay, so I can factor it as x minus 1 times that piece, x squared minus 4x plus 13. Excellent. We know that equals 0, so I just rewrote this as a product. Well, if a times b equals 0, then a equals 0, or b equals 0. And b is a quadratic. And how do we solve a quadratic? Well, is it factorable? Well, 13 is prime, so it's not factorable. I have to use the quadratic formula. In this case, again, x is equal to opposite b plus or minus square root b squared minus 4 times a times c. It looks like I'm getting in a negative under the radical, but I knew that because I knew I have two that are imaginary, so this should have an I come out of it. Okay, so x is equal to 4 plus or minus. Well, it turns out that this is, what's under the radicand here is negative 36 over 2. Well, this is equal to 4 plus or minus 6i over 2. And I want to make sure I don't lose you on my paper. This is x is equal to 2 plus or minus 3i. Okay, as we know, our imaginary answers always come out as conjugate pairs, but now I have all three zeros. Let's remind ourselves, we knew we had one real. here's the real one, and we knew we had two imaginary, and here are the two imaginary ones. So my solution set, I have a 1, I have a 2 plus 3i, and I have a 2 minus a 3i. Okay, those are my zeros. Okay, let's do another example. Again, helps to see. Let's do a 4th degree example. Again, pardon me for getting all my ducks in a row here. I had to do all these problems out ahead of time so that I wouldn't make too many mistakes. So let's go ahead and so I could keep track of what I'm doing and not make mistakes as it happens. Find all zeros of this 4th degree polynomial function. We do that by first setting it equal to 0. Okay, that's not factorable that I'm aware of. So we're going to have to find our zeros using our graph and our table if we have any. Let's notice this is degree 4, which tells us I have 4 zeros. Now, what are the possibilities? I have 4 zeros if multiples are counted individually. Okay, so possibilities. Okay, so the end behavior means that it's a 4th degree, so both ends go up or both ends go down. Okay, so what does that open up? One possibility, all 4 are real. So it would go maybe like this and hit the x-axis 4 times. Okay, or it could bump the x-axis and go down, and then go back up and bump the x-axis and turn around. You could have two that are real, but they're both multiplicity 2. So there are lots of possibilities here. Second possibility, we could have 2 that are real, and we could have 2 that are imaginary. That's a possibility. We're going to have 4. And the third possibility is all 4 are imaginary. Okay, I'll be honest with you. I have no idea how to find the zeros if they're all imaginary. So this one's not going to take place as far as we're concerned for this lesson, but it is a possibility, but we're not going to deal with it. And again, quite honestly, I don't know how to solve that. So it's going to be one of these two. Let's take a look at the graph. We're going to have a real 0 in there somewhere. So y equals, and let's clear this one out, and we know it's going to be x to the 4th minus 4x cubed minus x squared plus 14x plus 10, and let's zoom standard this and take a look. Well, it looks like I have a case where I have one real 0 of multiplicity at least 2. It could be 4. So I could have the same 0 happen 4 times. I don't know, but I either have all 4 real or I have 2 that are real and 2 that are imaginary, because when it touches and turns, that's multiplicity 2. Let's see if that's actually one that we can work with. I'm going to go to the table. And yep, right there, -1. That -1 is a 0. Okay, that -1 again, because it touches and turns, is a 0 twice, or it's a 0 all 4 times. I'm not sure. So it's one of these. All 4 are real, and they're all the same, or 2 are real and 2 are imaginary. It's one of those 2 possibilities. Okay, let's see here. So the table, the graph table shows a rational 0 at -1. Okay, So that means, again, x plus 1 is a factor. And because it touched and turned, it is multiplicity 2 or 4. I'll write those numbers out, make it a bit clearer what's a number and what's a word. 2 or 4. So I can either factor it out, I can have it as 4 times, or it's 2 times, and 2 of these are imaginary. Okay, so let's factor it out. I'll use synthetic. Let's take out a negative 1. It's going to come out at least twice. Let's take it out once. I have 4, 3, 2, 1. I'm good. My coefficients are 1, -4, -1, 14, and 10. I know I'm going to have a 0 remainder because I know -1 is a factor. -1 times 1 is -1. Add, get -5. -1 times -5 is 5. Add, get 4. -1 times 4 is -4. Add, get 10. -1 times 10 is -10. Add, get 0. Good, we knew that. So we're going to take this, and we know that now we can take this polynomial, and it factors as x plus 1 times x cubed. I've gone down by 1 degree, minus 5x squared plus 4x plus 10. Okay, is this factorable? I don't know. I don't think so. It might be factorable, actually. 2 x squared is x minus 5, -2. Nope, it's not factorable. But I know that -1 is a factor at least twice. So let's pull it out again. Okay, and these are our coefficients. 1, -5, 4, 10. And let's start again. We know that one, we know we're gonna have a 0 remainder because we know that -1 is a 0 at least twice. So let's go for it. -1 times 1 is -1. Add, get -6. Multiply, get +6. Add, get 10. Multiply, get -10. Add, get 0. But we knew that. So now we know we can rewrite this polynomial as x plus 1 times x plus 1. Well, we knew that -1 happened at least twice. And we have x squared minus 6x plus 10. Okay, is -1 a factor again? You know, if it's either 2 or 4. Well, I've already done it. This is a quadratic. It turns out it's not a factor again, but you could try it again and see, but it's not. So we know, again, all this equals 0. Here's an x equals -1, or x equals -1, or this quadratic holds our last 2 zeros. Okay, and it turns out that it does. Once we get to a quadratic, we're fine. So let's solve this quadratic, and we know they're imaginary. Okay, because the -1 doesn't occur 3 or 4 times, so these are imaginary. X is equal to opposite b plus or minus the square root. Let's make sure that I got all my paper up here for you. B squared is 36 minus 4 times a is 1 times c is 10. And this is all over 2 times a. Now we're simplifying. 6 plus or minus. Under the radical is a -4. There's our imaginary indication. So this is x is equal to 6 plus or minus 2i over 2. It's a common denominator. X is equal to 3 plus or minus I. Okay, so we have two zeros that are real. Well, we have 1 0 that's real. It happens twice, -1. And we have 2 imaginary zeros or non-real zeros. Our solution set is -1. Again, we know this happens twice. It has multiplicity 2. And then 3 plus an I and 3 minus an I. And there's our 4 total if we count this one, which has multiplicity 2, separately. All right, let's do one more example. Almost having too much fun, aren't we? Ha ha. Yeah, listen to me. Okay, one more example. It's taking a little while, but this does take a while. Let's take a look at another fourth degree, I believe. Okay, solve this fourth degree. It's already said equal to 0. What do we know? It's degree 4, which means we have 4 zeros. Okay, how are they? Well, possibilities. As we stated before, possibilities: 1, all 4 are real. 2, 2 are real. And 2 are non-real, also called imaginary. And 3, all 4 are non-real or imaginary. As I stated earlier, I don't know how to solve this one. So it's going to be one of those two. Let's take a look at our graph. See if we can find a rational 0 from our graph. Y equals clear. 2x to the 4th plus 3x cubed minus 11x squared minus 9x plus 15. I'm going to zoom standard to make sure I'm in the regular window. And here it comes, I think. 1, 2. Oh, I have all 4 real. They're all 4 real. 1, 2, 3, 4. All 4 of these are real zeros, okay? Are any of these rationals? Are any of them rational that I can work with using division? Let's go to my table. My table says, yep, you've got a rational at 1. There's a rational 0 at 1. So graph or table, I used the table, shows a rational, which means it can be written as a fraction, 0 at 1. So we know that x minus 1 is a factor. Okay, let's factor it out. Let's factor out that 1 and get the third degree left. My coefficients, I have all 3. I have all my powers. So 2, 3, negative 11, negative 9, and 15. Pull this one down. I know I'm going to get a 0 here. Let's check. 2 times 1, add. 5 times 1, add. Negative 6 times 1, add. Times 1. I got my 0, so I'm good. So I know that I have x minus 1 times 2x cubed plus 5x squared minus 6x minus 15. Okay. I don't think that this is... Can I factor this? I might can factor this. Let's see, can I factor this by grouping? If I pull out, this would be x plus 5. I think I can. Let's factor this by grouping. So I have x minus 1 equals 0, or 2x cubed plus 5x squared. I'm going to try this. Minus 6x minus 15 equals 0. Let's take out an x squared, and I'm left with x plus 5, and then let's take out a 3. No, I'm left with a 2x plus 5. Sorry about that. I'm left with a 2x plus 5, and then let's take out a 3, a negative 3, and I'm left with 2x plus 5. It is factorable by grouping. That worked. Okay, so what do I know? I can now further do it. That's a common factor, so I have x squared minus 3 times 2x plus 5 equals 0. Well, this one says that x is equal to positive or negative root 3, or this one says that x is equal to negative 5 halves. That worked out well. I didn't realize that could be factored by grouping. Sometimes cubics can be factored by grouping. I was going to go look for another rational 0. So I'm done. 1, negative 5 halves, positive root 3, and negative root 3 are my zeros. 1, negative 5 halves, negative root 3, and positive root 3. There you go. So sometimes it does help. Can you factor a cube by grouping, which we've done here and there? And it turns out in this case you can, and it allowed us to find the other zeros rather quickly. Notice that this one's rational and this one's rational. I could have found this one on the graph. These two are irrational, so I would have had to use the quadratic formula once I found this one to get that one. So there you have it. A lot of examples for you. Take your time, follow through carefully, make use of the graphing calculator and the graph and the table to find rational zeros and all the other stuff you know thus far.